السلام عليكم طلاب، كيف حالكم؟ أتمنى صحة وعافية. And today we're gonna review your EOT exam structure for the academic year 25-26, term 1. So, first question will be based on differentiate between ground state and excited state. Okay. Okay, so as we discussed before, the first question will be on differentiate between ground state and excited state. So, as you know, the ground state is the lowest allowable energy state of an atom. Okay, so the minimum amount of atom in we call it a ground state. This one is the ground state. And as you see here, the electron is close to nucleus, while excited state is an energized state. Okay? Energized means it will take energy in order to jump from the ground state to an excited state. Okay? So the first question will be the lowest energy state of an atom is called ground state. The answer is B. When a hydrogen atoms gain energy, its electron move to ground state, nucleus state, an excited state, or the same orbit. So, as I told you before, whenever atoms gain energy, will be on the excited state. So, the second question will be about, third question will be about figures, okay? So, which of the following is true about this figure 1 and 2? So, we have 3 correct answer and 3 wrong answer and 1 correct answer. As you see here, this is the sketch of the ground state. Ground. And this is the excited. So, electron in figure 1, which is this one, has more energy than figure 2, which is excited state. So this answer is completely wrong. Electron in the figure 1 has less energy than figure 2. Yes, of course, excited state has more energy than ground state. So this the correct answer. Option B. Second question, you have to relate between principal quantum number and the total number of orbitals. Okay, so here you have the first principal quantum number n that indicates the relative energy and size of an atomic orbital. So as n increase, the orbit become larger and electrons spend more time further from nucleus. So as energy increase, the total number of orbital increase and everything will be increased, okay? The size and the energy. And as you see here in the figure, here it can show you the relationship between the n principal quantum number and number of orbital. For example, n is equal 1, we have 1 orbital. N equal 2, we have 2 orbitals. And it will be larger than n equal 1. So it's just like an auditorium in the figure here, okay? As you go further from the center here, everything will be larger and increasing, okay? So In 1, we have s orbital. In 2, we have s and p orbitals. And number 3, we have s, p, d orbitals. And the last one will be containing the whole orbitals, which is s, p, d, and f. So, going back to the questions. As the value of principal quantum number increase, as I said before, everything will increase. Decrease is wrong, gets smaller wrong, closer to the nucleus wrong, and the orbitals becomes larger and energy increase. This is the correct answer. Which sublevel are presented in the second energy level, which is n equal to? As I told you before, you have to look here. It will be S and P. So, regarding the 1s and 2s orbital energy sublevel, which of the following correct? Both have different shape? Yes, because both of them are s orbital. So, this is wrong. 2s level sublevel is larger than 1s. Yes, because the energy level is different. So 2 is larger than 1. Both different in the number of orbital? No, because each one of them has one orbital. And can fit only 2 electrons. So the answer will be only 2. Third and sixth question will be upon the rules that control the electron configuration, which is of Pauli, and Hans rule. So, first thing you need to know is electron configuration is an arrangement of atom in the electron and the atom, okay? The arrangement of electron in the atom. Which we call electron configuration, and it will be ruled by 3 principles or rules, which is, the first one is of Bohr principle, which is state that each electron occupies the lowest energy orbital available first, then you go for the higher. So I can fit 1s first, then I can go for the 2s, and so on. I can continue to 2p, 3ps, and 3p, and continue filling the electrons, okay? Pauli exclusion principles state that the maximum of 2 electrons can occupy single atomic orbital, but only with the electrons will have opposite spins. This is the correct formula for the Pauli, okay? I cannot do like this. It's not allowable. For example, I have one electron and another electron in the same spin or direction of spin. This is completely wrong. While if I have them just like this is correct. It should be in the opposite direction spin. Hand rule, as you say, state that single electron with the same spin must occupy each equally before additional electron with opposite spin can occupy the same orbital. So I can start with half filling the orbitals, then I can continue once again with opposite spin electron. Okay, just as you see in the figure here. Which rule is applying here? So, as the electron with the opposite spin existing, this is hand rule is applied. Okay, so starting with 1s, 2s, then the 2b of Bohr is applied. Pauli exclusion principle always is applied. So the answer will be all of the above. So 4 possible electrons configuration for nitrogen atom are shown here. Which configuration violates hand rule? So as you see here, I have paired electron before I complete the half-filled orbital. So configuration A is violating hand rule, so I can pick it. B is fine with the hand rule, so I cannot pick it because it's not violating hand rule. Configuration C is corrupted. Why? Because I have paired electron with same direction of spin, so I can pick it, and here is empty. اوكي هذا فاضي يا شباب، فانا ما اقدر اتس violates hand rule، يتعارض مع hand rule. اوكي D configuration is always violates hand rule. Why? Because I have opposite spin in other orbital. ما في spin. Now look at the picture here. Which rule is begin broken? So as we see here, Pauli exclusion principle is applied, so I cannot pick it. Okay, you see here all electrons are paired with opposite spin, so Pauli is not correct. Hand rule is applied because everything is paired, and the one who has not obeyed here or began broken is of Bow principle. Okay, because it 1s orbital is not completely filled. So the wrong answer is here. An atom with phosphorus element has a total of 15 electrons. So P 15. Determine which sublevel is partially filled. So which orbital in phosphorus is not completed by electron? So here you have to make the electron configuration of phosphorus to know which orbital is not filled completely. So here I have 1s, walaikum salam, 2s, 2p6, and then 3s2. Here I have 12 electron. What's remaining is negative 12. I have 3 electron left, so it will be 3p3. Okay, so 3p3 is not complete, so the answer is 3b. The question 4 and 5, it will be based on electron configuration or energy orbital diagram and noble gas notation, which is this one, diagram orbital diagram, electron notation, and noble gas electron notation. Questions. Which of the following is the electron configuration for chlorine atom, which have 17 electrons? So here the key is I need to count the electrons. Okay, if it's 17, then okay, and to check the correct electron configuration. Here I have 16 electrons, so X on the A. Here I have 10 plus 7 is 17. Could be correct, but 3s, then I have 3b. So the answer here is correct. Incorrect. So C, if you find C, we have 17 electron, and with the correct sequence, which is the correct answer. And here I have 18 electron, so this will be wrong. Which element has the following electron configuration? 1s2, 2s2, 2p4. So the total electron is 8 electrons. So I have to find the element with 8 electrons. If you get fluorine, it's 9, and the negative charge here, it corresponds to 1 electron. So 9 plus 1 is 10. B have 8 electrons and no charge, so the answer is B, oxygen. Let's check C. C have the sodium ion, which is positively charged, so it's missing 1 electron. So the answer C have 10 electron. Okay? And D have 5 electrons, so the answer will be oxygen element. What is the noble gas notation of Al13? So 13 is in between 10, which is correspond to Ne, and 18. So to make this shortcut, you have to deal with the lowest number, which is 10. So I need to start with Ne, okay? After Ne, it will be 3s2, then 3b1. So He is completely wrong, Ar is completely wrong, and Ne here I have 3s2. So the total number of electrons is 12 here. So this is the wrong again. And the correct answer will be B. What is valence electrons for 7n? So again, how to find the valence electrons and to make the electron dot structure, you have to follow the highest quantum number or energy level, which is this one and this one. Okay? Then have the total of them, which is 3 plus 2 is 5. So selenium has 6 valence electron. Which is the correct electron dot structure for an selenium atom? So D is completely wrong because it's not the element symbol for selenium, because S for the sulfur. And here in the A, I have 7 electrons, so it's wrong again because selenium has only 6. B is correct, is not correct. Why? Because I have 3 electrons there, and the maximum number of electrons in one side is 2 electrons, not 3. So the correct answer here will be C. Okay, Shabab, I hope this can be benefit for you, and that's it for today. Thank you so much.